Good morning everyone. Now welcome to my channel Protein Academy. Now if you not subscribe my channel, then do subscribe. So whenever I upload the video, then you will get the notification and just click the bell icon. Now in today's video I will discuss about chemical bonding chapter of class 10 ICSE. Now it is very important chapter. That means the second chapter of class 10 book. Okay. Now here we will discuss how the bond between two atoms of elements formed. Okay. Now why they will form, why the atoms will combine together to form the bond or to combine together to form molecule or the compound. Okay, that one we will discuss here. Now normally, if we consider if we ask that why the atoms will form a compound or why the atoms will form a molecule. Normally the basic knowledge of this one, that normally atoms are not stable. We know that atoms are indivisible particle of the element and they cannot be created or cannot be destroyed also according to Dalton's atomic theory. But after that we know that atoms formed by electron, proton and neutron. So normally atoms are not, and it is an electrical neutron, so atoms are not independent. Okay, they tend to react with other elements or other atoms. Okay, so atoms are not independent. That means they are reactive. That means they are not stable. So atoms are not stable. Okay, so the first concept is the atoms are not stable. That means the energy of atom is very high. The energy of atom, of any atom, is very high. Energy of an atom is very high. Okay. Now normally in our everything want to be stable. Everything in our environment want to be stable. Okay. So likewise atoms want to be stable. As it is not stable, as its energy is very high, so it will want to get the stability by lower the energy. Okay, so as the atoms of an element are not stable and as the energy of the atoms are very high, so what it will tend to do, it will lower the energy to get the stability. Okay, so the answer is why the atoms will form the chemical bond or why the atoms will form a molecule. The answer is here, that why the atoms will form molecule or bond or compound, you can say. Why this will form? Because to get stability, to lower the energy and to get stability. To lower the energy and to get stability, atoms will combine with other atoms, maybe similar or different element, to form a molecule or a compound. To form a molecule or a compound. After that, it will be stable. So the reason why we are learning this chemical bonding chapter, because atoms are combining together to form a molecule and to get stability. So that is the reason why. Okay. Now normally atoms can form the molecule to get the stability by the formation of bond. Now that is we will discuss in this chemical bonding chapter. Okay. Now and their bonding is nothing but the attraction force between the atoms. Okay, attraction force between the atoms, and that are present in a chemical compound. Okay, and that is nothing but that we will discuss here in the chemical bonding chapter. Okay, understood? So your bonding is nothing but an attraction force between two atoms. Okay, which tends to get the stability by lowering the overall energy of a molecule. Okay, that is the chemical bonding chapter. Okay, now different kinds of chemical bond can form in different kinds of atom or in different kinds of molecule. According to the type of bond formed in different compound, the compounds are different. Okay, that means atoms can form ionic bond also, and it can form covalent bond also, and it can form coordinate bond also. Now those elements which will form the ionic bond, okay, they will tend to make the ionic compound. So the ionic compound will consist of ionic bond, covalent compound will consist of covalent bond. Okay, covalent compound will consist of covalent bond, and coordinate compound will consist of coordinate bond. Okay, so the compounds which have the ionic bond are called ionic compound. The compounds which have the covalent bond are the covalent compound, and the coordinate bond, they are the coordinate compound, actually coordination compound. Okay, so we'll discuss how these compounds or these bonds are formed. Individually we'll discuss in different videos. We'll discuss, and all the properties, how they are forming, or what are the characteristics of this bond, we'll discuss. Okay, individually. Now today we'll discuss about the ionic bond, or ionic compound. Okay, now the basic concept will be similar, with the same, that atom will try to be stable and will try to lower the energy. Okay, now for the ionic bond, for the formation of ionic bond, we required a metal and a non-metal. Okay, one metal and one non-metal. Understood? Now, what metal, which metal and which non-metal will take? The difference between the electronegativity of those two elements should be higher, should be very high, and they will participate in the formation of ionic bond. That means they will participate in the formation of ionic compound. They will form the ionic compound. So which element, that means atoms of the element, will participate in the formation of ionic compound? There must be a metal and non-metal. So metal and non-metal, pure non-metal and metal will combine together to form the ionic compound. And if the difference of the electronegativity between those two elements are very high, they will form the ionic compound or ionic bond. So first of all, metal and non-metal combine together to form ionic bond. Slowly we will go into the concept. Okay. Number 2, there must be high electronegativity difference, high electronegativity difference between the atoms which are forming the ionic compound. Okay, now you know the metal, about the metal, normally the metals are electropositive in nature. That means they will release electron to form a cation. Okay, and non-metal are electronegative in nature. They will tend to gain electron, accept electron to form an anion. Okay, now normally this will happen, that metal, those are electropositive. That means normally are alkali metals and alkaline earth metals will tend to release electron to form the cation. Okay, and after that the formation of cation, they will get the stability. Okay, we know that ions are more stable than the parent atom, so that's why to get the stability they will form the ion. Okay, so metal will form cation and non-metal will form anion. Metal will release electron and non-metal will gain electron. Okay, the number of electron released by the metal, okay, that will be accepted by the non-metal. If metal releases one electron, then non-metal will gain one electron. Okay, if there is one metal and one non-metal. So the process is one element will release electron and the other will gain electron. Okay, one atom of an element will release electron to form cation, and other atom of an element, may be similar or different, will gain electron to form an ion, and after that this cation and anion by the electrostatic attraction force combined together will form a neutral molecule or neutral compound. Will form a neutral compound actually. Okay, will form a neutral compound. So the cations and anion, maybe anions will be there, anion one or more, okay, will combine by electrostatic, that means by Coulomb's law, electrostatic attraction force to form a compound. Okay, to form a compound. Understood? Now the number of electron and they will get the stability and will get the stability. So the target is to be stable, to get the stability of an atom. Okay, and after getting the stability they will combine. Understood? Now say, now normally those metals will be, this is very easy. Those metals will be alkali metals or alkaline earth metals. Those metals will be alkali metals or alkaline earth metals. And for your class only, for halogens, the non-metals will be halogens, chalcogens, that means oxygen, like that. So you have to follow these things. Okay. So say I am taking one example just to give you. Now sodium, say sodium. Sodium is an alkali metal. Sodium is an alkali metal. Now before going into how to this compound is forming, how this compound, ionic compound is forming, you have to know the atomic number up to 20. Up to 20 atomic number you have to learn of all the elements. Okay. So here the atomic number of sodium is 11. Atomic number of sodium is 11. Now that means sodium has electronic configuration 2, 8, 1. In k orbit 1 electron. Okay. If you want to know how to write the electronic configuration, okay, you can see the video of atomic structure. Okay, your electronic configuration, how to write the electronic configuration. So there you will understand. So in k orbit 2, l orbit 8 and n orbit 1 electron. Now as this sodium is not having 8 electron in its outermost shell, we know that if the atom of an element having 8 electron in its outermost shell, it will be stable. Okay, it will be stable except helium and hydrogen. Okay, this rule is called octet rule. This rule is called octet rule. So if the number of electron in the outermost shell of an atom is 8, it will be stable. But it is not, if it is not, it will be not stable. So here this sodium is not stable because the outermost shell is this cell and having 1 electron. So this one is not stable. Okay. So for hydrogen and helium, duplet rule will be applicable. Duplet rule will be applicable. But for elements having the atomic number more than 3 or 4. Okay, that will, in that case, the octet will be applicable. So how you know the stability? That atoms, if the atoms have 8 electrons in the outermost shell, they are stable. So they will not react with other elements. Okay, so no need to form of the bonding, no need to form the compound. Okay, so I will discuss that one. So see here, this sodium is not stable because the outermost shell is not containing 8 electrons. So what it will try to do? It will try to make the outermost shell 8 electron. Okay, so what it will do? It will release 1 electron. It will release 1 electron because if it releases this electron, then the outermost shell will become 8 because this shell is not having electron. So the outermost shell will be 2,8. Outermost shell will be 2,8. So this is stable. Now as it released 1 electron, so here the number of proton is 11 and number of electron is 11. So after releasing 1 electron, the number of proton becomes 11 because it is not released, so it is remains same. But the number of electron becomes 10. So here the species it is formed by releasing 1 electron. Here the number of proton is higher than number of electron. Okay, so charge will be governed by the number of proton. So here the charge of proton will be given. So the species it is formed the cation. It is formed the cation. Understood? It is formed a cation. Now the number of electron, if here as 1 electron released, so 1 charge formed. If 2 electron will be released, then you can write 2 plus like that or plus 2. Okay, so here this metal after releasing 1 electron form a cation. Okay, now what is this process? Can you say? This process is called oxidation. This process is called oxidation. Okay, so metal will release 1 electron to form cation by the process of oxidation. Okay, and the non-metal, say one non-metal I am taking chlorine, having 2,8,7 electronic configuration because its atomic number is 17. So what it will try to do? It will release 7 electron? No. To make the outermost electronic configuration 8, it will accept 1 electron. It will be very easy. So it will accept electron to form the electronic configuration 2,8,8 and the outermost shell becomes Cl minus. Okay, why it is Cl minus? Because here the number of proton is 17, number of electron is 17. But here it is become number of proton 17 but number of electron 18. So charge will be governed by the negative charge. So it is an ion and the process is called reduction. Okay. So here you see the number of electron released by the metal, it is accepted by the non-metal. Here it is formed cation, here it is formed anion. So metal after release electron it will form cation and non-metal after gain electron it will form anion. After that this cation and anion will join together by electrostatic attraction force to form a compound, that is NaCl. That means Na plus Cl minus will join together to form NaCl. Now how it is formed we can show by a schematic diagram. That diagram is called Lewis dot diagram. Okay, or diagram of the formation of electrovalent bond. Okay, this one we can form. Understood? Diagram of the formation of electrovalent bond. Okay, now that diagram is shown by the Lewis. Okay, now just I am giving one example that what you have to do. First of all, you have to write. Just I am doing the formation of sodium chloride. Okay, writing the formation of sodium chloride. Now here, this sodium chloride is formed by Na and Cl. So what you have to do? You have to write the electronic configuration here of sodium. It is 2, 8, 1, and for chlorine 2, 8, 7. Now you have to show the outermost electronic configuration. Outermost electron you have to show here by a dot. By a dot. Here sodium having one electron. Sodium having one electron at the outermost shell. So one dot you give. This representation is called Lewis dot representation. Lewis dot representation. Lewis told that if you have to, before formation of a bond, before formation of a compound, you have to show the outermost electron, because this outermost electron will participate in the formation of bond. Only the outermost electron will participate in the formation of bond. So here I have given one dot. Okay, this denotation is called the Lewis dot. Okay, again chlorine having 7 electron. 7 electron you have to write as a pair. Okay, now everyone will try to make the outermost electronic configuration 8. Sodium also and chlorine also. So what it will do, sodium will release one electron. It is given to chlorine. So sodium formed here after giving one electron Na+, and chlorine is accepted this electron, so it is formed Cl-. Now see what is the electronic configuration, becomes 2, 8 and here 2, 8, 7. Sorry, 2, 8, 8. Now these will join together to form a NaCl. Okay, so this is called sodium chloride. Likewise, you can do the formation of other compound. But the main thing you have to learn that metal will release electron, non-metal will gain electron, metal will form the cation, non-metal will form the anion, and they will join by electrostatic attraction force to form the compound. And after formation of cation and anion, both will be stable. And here for most of the metals will be alkali metals like lithium, sodium, potassium. Okay, alkaline earth metals, calcium, magnesium, you will see. Okay, so in next video I will discuss more example of ionic compound and some of the concept, again some other properties of the ionic compound. In next video I will discuss. So today video is up to this. You try to do for calcium chloride and magnesium chloride. If you can, potassium chloride you can do, I think, if you know the atomic number. So chart, I will write one chart next day of all the atomic numbers. So if you like this video, then do like, comment and subscribe my channel.